If you are building a rack system, you already know chunking matters. Sometimes you chunk because you have to. A document may be too long for the embedding model or too large to send into the large language model's context window, but often you chunk because you want better retrieval. A user query usually does not need the whole document. It needs the right paragraph, section, table, or answer span. The challenge is that chunking is not just about choosing a chunk size. It affects your storage model, your metadata strategy, your keyword scores, your ranking pipeline, and ultimately the quality of what reaches your LLM. In this video, we'll show how Vespa gives you both chunk-level retrieval precision and document-level architectural simplicity. We'll look at the chunking problem, how Vespa stores chunks, what the multi-vector landscape looks like, and why ranking down to the right chunks is where the real difference shows up. Now let's get started. Every rack system starts the same way. You take your documents, split them into chunks, and turn each chunk into a vector. Simple, until you decide how to store them. If you use one record per chunk, you have to copy the document's metadata onto every chunk. Title, author, date, permissions, source, category. Now one document can become hundreds of chunk records. Update the title? You may need to update hundreds of rows, and keyword scoring can quietly drift because the same title or metadata gets repeated again and again. If you use one record per document with child chunks, you avoid some duplication, but now you are managing parent-child relationships, joins, and mapping logic. These are the chunking design crossroads, and the painful part is that the wrong decision often does not show up until you are already at scale when it is expensive to undo. Vespa removes the hardest part of that decision. You keep one document. All of its chunk embeddings are stored in an array of vectors inside that document. And all of those vectors share one set of metadata. No parent-child modeling, no duplicated titles, no repeated metadata fields. Keyword scoring stays clean because every metadata field appears exactly once. And when you update the document, you update one document, not hundreds of chunk records. You still choose your chunk size and chunking method. That decision is still yours because it depends on your content, but everything after that, storage, metadata management, updates, and ranking becomes dramatically simpler. Before we go further, it is worth clarifying something. When people say multi-vector retrieval, they may mean different things. The first meaning is chunk-level vectors. This is the core chunking model we have been talking about. You start with one document, split it into chunks, and create one vector for each chunk. So the document is still one document, but it has many chunk vectors. That gives each section of the document its own retrieval signal while keeping the metadata and document structure clean. The second meaning is token-level vectors. This is the Colbert-style approach. Instead of representing a chunk or passage with one vector, the model represents it with many smaller vectors, often one vector per token. At query time, each query token looks for its best match inside the passage, and those best matches are combined. That is called late interaction, or maxim. So there are two levels. Chunk-level vectors help you find the right part of the document. Token-level vectors help you score that text more precisely. Vespa supports both. Now that we have explained chunk-level vectors and token-level vectors, let's be clear about the competitive landscape. Quadrant, Weaviate, Milvus, Elasticsearch, and OpenSearch have all moved toward multi-vector support in different ways. That is a good thing. All it means the industry is converging on the same idea. Documents often need more than one vector, but not every system means the same thing when it says multi-vector. This distinction matters because multi-vector support is not one single feature. Some systems mean multiple vector fields. Some mean nested passage vectors. Some mean Colbert-style token vectors. The question is not whether you can store multiple vectors, it's whether you can rank and retrieve the right chunks. This is where Vespa really shines. ROG needs the right passages to put into the large language model's context window. Most multi-vector search gives you one score for the document. That tells you which document is probably relevant, but it does not necessarily tell you which chunks inside that document are the best ones to send to the LLM. But Vespa can rank down to the chunk. First, Vespa finds the best candidate documents. Then, inside each document, it scores the individual chunks. Those chunk scores can use vector similarity, keyword relevance, metadata, freshness, business logic, or a blend of signals. And because the chunks live inside the document, Vespa can rank them with the full document context available. This is layered ranking, ranking to the chunk. So instead of sending the whole document or doing chunk filtering in your application code, Vespa returns only the best chunks. The result is simple. Only the most relevant passages reach your large language model. No bloated context, no wasted tokens, no filler, and no accuracy sacrifice just to make the architecture simpler. Now we've seen the core problem. Chunking is not just about splitting text. It affects how you store chunks, how you rank them, how you choose the best passages, and what finally reaches the LLM context window. Vespa handles much of that inside the schema and ranking profiles. So let's make the simplicity claim concrete. What actually disappears from your application code base? In a typical vector database setup, a lot of chunking complexity gets pushed into your application code. You manage chunk to document IDs. You duplicate metadata across chunks. You clean up orphaned chunks after updates. You join chunks back to parent documents. You choose which chunks should go into the LLM context window. And if you want hybrid retrieval, you may be stitching together keyword search, vector search, and re-ranking yourself. In Vespa, much of that disappears. You have one document, one metadata record, one update path, no parent-child join, native rank profiles, and layered ranking to return the most relevant chunks. That is the real payoff. Less code, fewer failure modes, cleaner, better retrieval. Don't just take our word for it. Look at Perplexity. Perplexity has published what great RAG actually requires: completeness, freshness, and speed, fine-grained content understanding, and hybrid retrieval and ranking. Their conclusion is especially important. Great AI search has to treat the individual sections and spans of documents as first-class units, not just whole documents. That is exactly the idea behind ranking down to the chunk. They also found that many vector databases lack support for even simple Boolean filters, while traditional search engines provided only primitive semantic retrieval and ranking. Vespa stood out because it eliminates these trade-offs, offering powerful filtering, retrieval, and ranking capabilities alongside state-of-the-art vector search. Perplexity built its search stack on Vespa because it could combine large-scale indexing, real-time updates, hybrid retrieval, multi-stage ranking, and low-latency execution in one system. This is not a toy deployment. Perplexity indexes billions of web pages and user files, stores documents together with collections of vector embeddings and structured metadata, and serves results in about 100 milliseconds, thousands of times per second. Perplexity has beaten Google on both search speed and relevance. The reason is simple. Great AI answers start with great search. The speed and quality behind Perplexity's search experience are powered by Vespa. Vespa has been doing multi-vector search since 2014, years before vector search became a buzzword. One document, every chunk ranked, the right answer returned. That is the payoff: speed, quality, and scale. Ready to simplify your RAG architecture and improve retrieval quality? Start with the self-paced Vespa 101 workshop and see how easy it is to put this together, or speak with a Vespa engineer to discuss your use case and get a fast start with a simpler, better chunking architecture.